So here are some quick remarks about sets. We'll say that X is a set if X is a collection of objects. Let's say capital X is a set and little x is an object. We'll say that little x is a member of capital X if little x is in capital X. Instead of saying member, some people will say element. So here's some notation for writing down a set. This is called roster notation. So let capital X be a set. If you want to write down capital X, you'll write down all the members of X in between braces. The order of the members doesn't matter, and repetition doesn't matter. So here's an example of this. So if you write Romeo and Juliet between braces, this stands for the set of people Romeo and Juliet. If you write Romeo Juliet, that's the same set as Juliet Romeo. And if you write Romeo Juliet Juliet, that's the same set as Romeo Juliet. Order and repetitions don't matter because when you list the members in braces, that just means that each object listed is a member of the set. Repeating an object is just redundant. If you repeat an object, then you've just told everyone twice that the object is in the set. Here's some notation for membership. If little x is an object and capital X is a set, then we'll write little x and then this E looking symbol. You read this as in. So we'll write x is in capital X whenever little x is an object in capital X. If little x is not in capital X, then we'll write a strike through. So this E looking symbol. Here's an example of this. Romeo would be in the set of Romeo and Juliet, but Mercutio would not be in the set of Romeo and Juliet. So there's a special set called the empty set. This is the set that has no members. So we'll call that the empty set, and we'll write this symbol to stand for the empty set. It's like a Norwegian O. You could also write braces with nothing in between them to stand for the empty set. So here's an example of the empty set. Let's say that capital X is the set of days that begin with the letter A. So there are no days like this. So the set X has no objects in it, so X is empty. So you can think of a set as being like a bag that can hold stuff. The empty set is like an empty bag. Even though the bag has nothing in it, this empty bag is something you could talk about still. So here's what it means for one set to be a subset of another set. Let's say capital X and capital Y are sets. We'll say that capital X is a subset of capital Y. If it's true that whenever little x is in capital X, then little x has to be in capital Y. So capital X is a subset of capital Y if everything that shows up in capital X also shows up in capital Y. We'll write this whenever X is a subset of Y. So you'll write a sideways U with a bar underneath it. That just means that X is a subset of Y. Here's an example of this. So the set of letters AB, that's a subset of these letters ABC, because everything that shows up in this first set also shows up in this second set. The set AD is not a subset of ABC, because it's not true that everything that shows up in this first set also shows up in this second set. So if capital X is a set, then capital X will be a subset of itself, and if capital X is a set, then the empty set is a subset of X. Here's another notation for writing down sets. This is called builder notation. Some sets are too big to list all their members in between braces. So to write down a big set, say the set of all poems written by Bukowski, we'll write something like this. Okay. You read this as the set of X such that X is a poem written by Bukowski. So these braces tell you that you're dealing with a set. X is basically a pronoun, and you read this colon as such that, and then you say the property that these objects are supposed to have. So any object X that has this property will be a member of the set. Here's a diagram of what it looks like. So you read these braces as the set of, this is X such that, X is a poem written by Bukowski. Let's look at a couple of examples of builder notation. Here I want to find the set of X such that X is a month. So here's the set of months. It's January, February, March, and so on to December. So if you wrote the set of X such that X is a month, you could also write that set using roster notation by listing out all the months. Here's another example. Let's find the set of X such that X is a month that starts with J. This would be all the months that start with J. You could write that set in roster notation like this. It's the months January, June, and July. Now I want to find the set of X such that X is a month that starts with M. This will be all the months that start with M. So you could write this in roster notation like this. It's just the months March and May. Here's another example. Let's find the set of X such that X is a month that starts with B. So there are no months that start with B, so this is just the empty set. Here's another example. I want to find the set of X such that X is a state that starts with A. So we'll just list all the states that start with A. So here are those states: Alabama, Alaska, Arizona, and Arkansas. Here's another example. I want to find the set of X such that X is a state that borders California. So those states are Oregon, Nevada, and Arizona. So here's one advantage of this builder notation. I can still talk about this set even if I don't know exactly which objects are in the set. So there are two advantages to this builder notation. The first advantage is that if I have a whole bunch of objects here, I don't have to list them all out. I could just describe the set quickly by giving some property that all the members have. That's the first advantage of this builder notation. The second advantage of this builder notation is that I could still write down this set even if I don't know exactly which objects are supposed to be here. If I wanted to find the set of X such that X is a member of Led Zeppelin, I would just list out the members of Led Zeppelin. So here are the members of Led Zeppelin: Robert Plant, Jimmy Page, John Bonham, and John Paul Jones. Again, in order to write down the set, I don't need to know the actual members of Led Zeppelin. I could just write this builder notation down. If I wanted to find the set of X such that X is an element in a water molecule, this would be the set hydrogen and oxygen. If I wanted to find the set of X such that X was a US president and a US Supreme Court justice, we would list all the people who were both a US president at one time and a US Supreme Court justice. There's only one person like that. That's William Howard Taft. So those are some examples of this builder notation. This allows you to write down a set by giving some property that all the members have. So I'll write a colon equals whenever I'm defining the thing next to the colon to be equal to the other thing. So if I write A colon equals B, this just means that A is defined to be equal to B. So you think of A as a shorthand for B. Here's an example. If I say that P is defined to be this set, the set of X such that X is a poem written by Bukowski, then all of these poems would be members of P, because P is just a shorthand for this set. So if you've got two sets, you could take their union. So let's say that capital X and capital Y are sets. We'll define a new set. So we'll write this new set as X, and then we'll write a U here, and then Y. So this is defined as the set of all the objects Z, such that Z is in X or Z is in Y. So the set X, U, Y, it's the set that you get if you dump the members of X and the members of Y together into one set. So we'll call this set X, U, Y. We call that the union of X and Y. You could also read X, U, Y as X cup Y. Here's an example of taking unions. if X is the set ABC and Y is the set CDE, then when you take the union, you'll just dump these two sets together, so you'll get all those letters. That'll give you A, B, C, D, and E. If you have two sets, you could also take their intersection. So let X and Y be sets. We'll define X with an upside down U and then Y. We'll define that as a set of objects Z, such that Z is in X and Z is in Y. So X upside down U, Y is the set of members that X and Y have in common. We'll call this set the intersection of X and Y. You could also read this as X cap Y. Here's an example of taking the intersection. So if X is a set ABC and Y is a set CDE, then to take the intersection, you'll just find the objects that show up in both sets. So C is the only object that shows up in both of these sets. So the intersection just has this object C. So you could think of the intersection as where the sets overlap. If you have two sets, you could also form the complement. So let's say X and Y are sets. We'll define X and then a backslash Y to be the set of objects X, such that X is in capital X and X is not in capital Y. So X backslash Y is the set that you get if you start with X and you throw out anything that's in capital Y. So we'll call this the complement of Y and X. You could also read this as X without Y. Here's an example of complements. So if X is the set A, B, C, D, E, and Y is the set A, D, E, F, then X without Y would be B, C. So these are the only objects that are left over. If you start with X, so you start with X here, and you throw out anything that's in Y. So you start with X here, and you throw out anything that's in Y. So if you start with these objects, and you throw out anything that's in Y, you'll be left with B and C.